In geology, a rock is a naturally occurring solid aggregate of one or more minerals or mineraloids. For example, the common rock granite is a combination of the quartz, feldspar and biotite minerals. The Earth's outer solid layer, the lithosphere, is made of rock. Rocks have been used by mankind throughout history. From the Stone Age, rocks have been used for tools. The minerals and metals found in rocks have been essential to human civilization. Three major groups of rocks are defined: igneous, sedimentary, and metamorphic. The scientific study of rocks is called petrology, which is an essential component of geology. Classification. At a granular level, rocks are composed of grains of minerals, which, in turn, are homogeneous solids formed from a chemical compound that is arranged in an orderly manner. The aggregate minerals forming the rock are held together by chemical bonds. The types and abundance of minerals in a rock are determined by the manner in which the rock was formed. Many rocks contain silica, a compound of silicon and oxygen that forms 74.3% of the Earth's crust. This material forms crystals with other compounds in the rock. The proportion of silica in rocks and minerals is a major factor in determining their name and properties. Rocks are geologically classified according to characteristics such as mineral and chemical composition, permeability, the texture of the constituent particles, and particle size. These physical properties are the end result of the processes that formed the rocks. Over the course of time, rocks can transform from one type into another, as described by the geological model called the rock cycle. These events produce three general classes of rock: igneous, sedimentary, and metamorphic. The three classes of rocks are subdivided into many groups. However, there are no hard and fast boundaries between allied rocks. By increase or decrease in the proportions of their constituent minerals, they pass by every gradation into one another. The distinctive structures also of one kind of rock may often be traced gradually merging into those of another. Hence the definitions adopted in establishing rock nomenclature merely correspond to more or less arbitrary selected points in a continuously graduated series. Igneous. Igneous rock forms through the cooling and solidification of magma or lava. This magma can be derived from partial melts of pre-existing rocks in either a planet's mantle or crust. Typically, the melting of rocks is caused by one or more of three processes: an increase in temperature, a decrease in pressure, or a change in composition. Igneous rocks are divided into two main categories: plutonic rock and volcanic. Plutonic or intrusive rocks result when magma cools and crystallizes slowly within the Earth's crust. A common example of this type is granite. Volcanic or extrusive rocks result from magma reaching the surface either as lava or fragmental ejecta, forming minerals such as pumice or basalt. The chemical abundance and the rate of cooling of magma typically forms a sequence known as Bowen's reaction series, after the Canadian petrologist Norman L. Bowen. Most major igneous rocks are found along this scale. About 64.7% of the Earth's crust by volume consists of igneous rocks, making it the most plentiful category. Of these, 66% are basalts and gabbros, 16% are granite, and 17% granodiorites and diorites. Only 0.6% are syenites and 0.3% peridotites and dunites. The oceanic crust is 99% basalt, which is an igneous rock of mafic composition. Granites and similar rocks, known as metagranitoids, form much of the continental crust. Over 700 types of igneous rocks have been described, most of them having formed beneath the surface of Earth's crust. These have diverse properties, depending on their composition and the temperature and pressure conditions in which they were formed. Sedimentary. Sedimentary rocks are formed at the Earth's surface by the accumulation and cementation of fragments of earlier rocks, minerals, and organisms, or as chemical precipitates and organic growths in water. This process causes clastic sediments or organic particles to settle and accumulate, or for minerals to chemically precipitate from a solution. The particulate matter then undergoes compaction and cementation during at moderate temperatures and pressures. Before being deposited, sediments are formed by weathering or earlier rocks by erosion in a source area, and then transported to the place of deposition by water, wind, Ice, mass movement or glaciers. Mud rocks comprise 65%. Sandstones 20 to 25% and carbonate rocks 10 to 15%. About 7.9% of the crust by volume is composed of sedimentary rocks, with 82% of those being shales, while the remainder consist of limestone, sandstone and arkoses. Sedimentary rocks often contain fossils. Sedimentary rocks form under the influence of gravity and typically are deposited in horizontal or near horizontal layers or strata and may be referred to as stratified rocks. A small fraction of sedimentary rocks deposited on steep slopes will show cross-bedding where one layer stops abruptly along an interface where another layer eroded the first as it was laid atop the first. Metamorphic. Metamorphic rocks are formed by subjecting any rock type sedimentary rock, igneous rock or another older metamorphic rock to different temperature and pressure conditions than those in which the original rock was formed. This process is called metamorphism, meaning to change in form. The result is a profound change in physical properties and chemistry of the stone. The original rock, known as the protolith, transforms into other mineral types or else into other forms of the same minerals, such as by recrystallization. The temperatures and pressures required for this process are always higher than those found at the Earth's surface, temperatures greater than 150 to 200 degrees Celsius and pressures of 1500 bars. Metamorphic rocks compose 27.4% of the crust by volume. The three major classes of metamorphic rock are based upon the formation mechanism. An intrusion of magma that heats the surrounding rock causes contact metamorphism a temperature-dominated transformation. Pressure metamorphism occurs when sediments are buried deep under the ground. Pressure is dominant and temperature plays a smaller role. This is termed burial metamorphism, and it can result in rocks such as jade. Where both heat and pressure play a role, the mechanism is termed regional metamorphism. This is typically found in mountain-building regions. Depending on the structure, metamorphic rocks are divided into two general categories. Those that possess a texture are referred to as foliated. The remainder are termed non-foliated. The name of the rock is then determined based on the types of minerals present. Schists are foliated rocks that are primarily composed of lamellar minerals such as micas. A gneiss has visible bands of differing lightness, with a common example being the granite gneiss. Other varieties of foliated rock include slates, phyllites, and myelinite. Familiar examples of non-foliated metamorphic rocks include marble, soapstone, and serpentine. This branch contains quartzite a metamorphosed form of sandstone and hornfels. Human use. The use of rocks has had a huge impact on the cultural and technological development of the human race. Rocks have been used by humans and other hominids for at least 2.5 million years. Lithic technology marks some of the oldest and continuously used technologies. The mining of rocks for their metal or content has been one of the most important factors of human advancement, which has progressed at different rates in different places in part because of the kind of metals available from the rocks of a region. Mining. Mining is the extraction of valuable minerals or other geological materials from the earth, from an ore body, vein or seam. This term also includes the removal of soil. Materials recovered by mining include base metals, precious metals, iron, uranium, coal, diamonds, limestone, oil shale, rock salt and potash. Mining is required to obtain any material that cannot be grown through agricultural processes, or created artificially in a laboratory or factory. Mining in a wider sense comprises extraction of any non-renewable resource. Mining of stone and metal has been done since prehistoric times. Modern mining processes involve prospecting for ore bodies, analysis of the profit potential of a proposed mine, extraction of the desired materials and finally reclamation of the land to prepare it for other uses once the mine is closed. The nature of mining processes creates a potential negative impact on the environment both during the mining operations and for years after the mine is closed. This impact has led to most of the world's nations adopting regulations to moderate the negative effects of mining operations. Safety has long been a concern as well, though modern practices have improved safety in mines significantly. See also. References. External links, media related to rocks at Wikimedia Commons, the dictionary definition of rock at Wiktionary.